Hello, everybody. This is us. Thank you all 17 of you so far for coming. The last session I did with slides ran a little behind, and we had 10 fewer slides than we have on our presentation. So we're gonna just go straight into this and introduce ourselves in there, I think. All right. Oh, one thing actually before I do that, I do need my notes. So, presenter view. Yeah, there we go. Okay, we're good. We will survive this. Share.
That would be great.
Okay. Oh, but that's the wrong slide. Oop. Hold on. Hold on. There we go. All right. So thanks everybody for coming. Let's leap right into this. I'm Benjamin Jacobs of Wittenburg to Westphalia podcast. She's Raven Forrest Friscalzo of the Tiny Vampires podcast. And we're going to be talking about how public health and urban planning have interacted in the past as they attempt to combat disease. So I'm going to take the first couple slides and try and get through this. Raven, did you want to say anything to start, or should I just go? Okay. All right. So in modern times, health outcomes tend to be far better in cities than in rural areas. I'm going to breeze through this point, but just to show proof, I have actual charts and graphs. The one on the right is all cause U.S. mortality rates, rural versus urban, age-adjusted cause mortality rate per 100,000 over time. So you can see that rural mortality rates are higher, and as you would expect, that is reflected in the life expectancy at birth, which is the other table. It breaks things down a lot, but the main point is just generally that if you're in an urban area, there's a whole bunch of reasons that you end up with better health outcomes. This was not always the case. Getting actual charts and tables and graphs and stuff can be a little bit hard, but in pre-modern times, it's generally accepted by historians that survival rates were much better in rural areas, and urban areas were basically sinks of population. This particular piece of data is really interesting. They looked at the survival rate of Union Army veterans between the time that they were discharged in 1866 and when the study was done in 1900, and broke it down by a bunch of different factors. But this chart shows us that survival rates were much, much, much lower in urban areas. So the question is, what changed? Very quickly, we should define what public health and urban planning are. I'm not going to read this block of text. These are both very nice definitions. I was happy to find them, but I will let you all go read them later in the replay or whatever. Basically, what often happens is that there's a lot of overlap between these two groups. Public health officials are trying to shape public policy to protect lives, and urban planners are just more generally attempting to shape public policy to improve the quality of life for people. So there's a lot of overlap, and I think it's just fair to say really quickly, because a public health official, you can sort of conceptualize what that is. For an urban planner, a lot of times our role, one of the things that we're most trained to do is we sit around a table, we've got the mayor over there, we've got a couple engineers, we've got a doctor, and we just need to be literate in all those fields enough to translate what they're saying to the mayor or the public or whatever. It's also just fair to say that as a discipline, urban planning didn't really start until the 1980s. Like, no one, in some sense, there were urban planners going back to the Harappan civilization in the Indus River Valley, but no one had degrees in urban planning until the 1980s or thereabouts. So a lot of the people we're going to be talking about today, in some ways, are just enthusiastic amateurs. So pass this over to Raven.
Yeah, so when we think about disease and the ways that a disease can transmit from one person to another, or between an animal and a person, say a parasite causing disease directly, or something like the swine flu passing from a domesticated animal to a person. And then there are also obviously environmental factors, contaminated water and food and things like that. So if you can kind of think about these from a rural perspective versus an urban perspective, you can see how living in cities would kind of increase many, if not all, of these issues. Slide, please. There's my beautiful cityscape. Okay, one more. So we're gonna basically break this down into 3 examples that we thought were really great for really showing this point of how a particular disease kind of resulted in a particular urban environment change. So our examples are tuberculosis, cholera, and I put malaria here, but it's basically mosquito-borne diseases in general, and how they resulted in things like city parks, the reversal of the Chicago River, and ditches in mostly in on the East Coast of the United States. Okay, so tuberculosis we'll start off with. It's a bacterial pathogen. It's hard to overstate how incredibly important it was as a part of people's lives in the early 1800s. It was the #1 killer in the U.S. In the 1800s or in the 1900s, and it killed. You can click. It killed one. Continue. I animated my slides and now it's going to mess everything up. Sorry. I got fancy. Yeah, keep going. Okay, there you go. Okay, so it one more. It killed 1 out of every 7 people in the United States. So if you can think of like how much that would impact people constantly living in fear of this disease. One of the interesting factors when it comes to our particular talk is that malnutrition and undernutrition were a really big factor in whether people survive a bout with tuberculosis or not. Go ahead.
A little more?
Yeah.
There you go.
There we go. Okay, so the symptoms of tuberculosis. Sorry to like laugh through something so terrible. One of the things that a lot of us know is that tuberculosis used to be called consumption. This is because it caused chronic wasting, regardless of how much people would eat. For one thing, they would lose their appetite, and it causes them to slowly kind of waste away, as if they're being consumed from the inside. There's a lot of coughing, chest pain, weakness, and this is a result of the bacteria living in someone's lungs and causing something called caseation. So the bacteria is basically turning the tissue into a dry cheese-like substance that you can see from on this lung on the slide. There's all of these white marks, and those are that degradation in the lung. And that eventually leads to, as you can see in the upper part of the lung, these holes. And that results in bleeding into the lungs and eventually organ failure. So it's a really terrible, long, drawn out way to die. Slide. So tuberculosis transmission happens. It's incredible. It actually only requires just a few bacteria to be breathed in before you actually get the disease. So the R naught, or for every one person who gets the disease, how many people are expected to get the disease, transmitted from that person is 4.3. So for every one person sick, 4 and a third person ends up with tuberculosis. For reference, COVID-19 has a 2.2. So we're all like kind of experienced with how incredibly infectious COVID is. So it's more than twice as infectious. And so a lot of this is transmitted by coughing, sneezing, any kind of salival contact, to the point where, as you can see from these advertisements, even something as simple as kissing a baby was really highly discouraged. Right.
So humans have been dealing with tuberculosis for centuries, but as America began founding these massive industrial cities and science began improving, authorities started to think they could do something about it. But initially, their theories were somewhat lacking, which is going to be a running theme. The miasmatic theory of disease stated that diseases were caused by the presence of miasmas, which are poisonous emanations from putrefying carcasses, rotting vegetations or molds, and invisible dust particles inside dwellings. Basically, anything that smells bad is going to kill you, theoretically. This idea was an improvement over the evil spirits theory of disease. But of course, the previous idea was the humoral theory of health, which is that you needed to balance your humors. The humoral theory was the top theory for a millennium or so, centuries at least. The problem is that it didn't really explain plagues. Like, there'd be an outbreak of plague. Did everybody in the city have humid blood? How did that happen? So the miasma theory contributed somewhat by linking some sort of environmental factor to health outcomes. And it is worth saying that if your water smells like poo, you probably shouldn't drink that water. And so at that level, that's there's something to it. Unfortunately, human beings can't actually see, smell, or taste down far enough to prevent themselves from actually getting sick. There's with tuberculosis, as Raven just said, you can just get a couple germs, and humans aren't focused enough with their natural senses to be able to detect that. The conditions of this era were, of course, pretty terrible. This is the era of the satanic mills and everything that went along with that. In the interest of time, I'm going to skip reading this. So there was more going on at this time. Outside of the medical field, which was thinking about miasmas and things like that, you had the Romantic movement in literature and art going on. And people like Wordsworth, Ebenezer Howard, and Thoreau in this country were popularizing walking and the healing effects of nature and all that stuff. And it wasn't too long before social reformers started to say, well, hey, that's nice for rich people building their giant gardens and everything and taking a cure by walking around their giant private estates. But urban poor people don't necessarily have access to that kind of thing. One of the earliest cities to do reforms along these lines was actually London, where they built sidewalks so that people didn't need to walk ankle deep in filth on the streets. But inevitably, these concepts came to the United States, where they ran into one Frederick Law Olmsted, who was something of a dilettante or a public intellectual, mostly working as a journalist and just submitting opinion pieces and spending his time learning about things. He did know about germ theory, but the miasma thing was so deeply seated that he began saying that it was very important that we have these parks to get away from these bad smells. He sort of adapted miasma theory concepts to germs by saying that the air would be disinfected by sunlight and foliage and things like that, as you can see in this quote. But the most interesting thing about Frederick Law Olmsted is that as a public intellectual, he eventually got hired to take care of this boondoggle in New York City called Central Park. And this became his calling. He sort of became the first landscape architect in the United States, and he ended up building park systems all over the country based on his own personal ideas. He was a very unique individual. In terms of tuberculosis, of course, he wasn't alone in sort of linking it to older miasmatic concepts. Even after it was verified that TB was caused by bacteria, which could be combated by good hygiene, part of the combating of good hygiene was considered to be air and light. So, you know, there were these massive public health campaigns about getting kids lots of time outside. In New York City, they had, they were called baby boxes or baby cages, where they were metal cages that they would secure on the outside of windows, and you'd put your baby out there. And of course, if you got TB, it was thought that these same treatments would help. So they founded these sanitariums across the country, like in the middle photograph there, where their treatment for everybody was to put them outside. And then, of course, on the public health side, Frederick Law Olmsted was out there building parks left, right, and center. Now, there was a gradual reduction in tuberculosis in this country. I will go out on a limb here and say that it wasn't due to parks. Sun and air do not, in fact, kill tuberculosis. I mean, sunlight does, but that's not going to keep you from getting TB. The most effective treatments were quarantines. They started coming up with the first effective pharmacological treatments in the 1940s, and within a decade or two came up with the modern cocktails that we use today. Even beyond that, though, building codes. After the Triangle Shirtwaist Fire in 1911, you know, real modern fire codes and building codes came in, which imposed some hygiene, health, and safety standards on people, on landlords. And then, of course, after World War II, the rise in the standard of living in the United States meant that people had access to washing machines and showers and all that fun stuff. So I'm going to turn it back to Raven to talk about the fun topic of cholera.
So cholera is another bacterial disease, but it causes diarrheal symptoms, and it's incredible how rapidly something like cholera can kill you. A lot of people would get sick in the morning and be dead by the evening. This illustration of this woman, of like essentially a before and after. So it's also really important to understand about cholera that it has a history of pandemics. So we've been dealing with COVID for just a handful of months. So you can imagine something, a cholera pandemic, something that can kill you. You know, you can get sick in the morning and be dead by evening, and having 6-year, 15-year, 24-year long pandemics. It was a huge part of the culture around the world. So next slide, please. Yeah, keep going. Is this the right slide? Oh, interesting. So cholera, the bacteria, once it gets inside of your gut, starts to destroy the lining of your intestines, and the toxin creates an environment where your food and water, all of that nutrition, instead of moving from the inside of your gut into your body, actually starts to move the other way. And that's what's causing these really watery diarrhea and vomiting, as this illustration from China shows. This loss of water and nutrition in such a rapid way is what ends up causing organ failure and eventually death. So cholera is also an incredibly infectious disease. Its R0 value is 2.72, so for nearly 3 people for every 1 person sick. It's transmitted from somebody with cholera shedding those bacteria from their gut, and if they're not washing their hands, or if they're going to the bathroom into an environment where that feces or vomit can get into the water supply or into the food supply by, say, spreading human manure on fields, then it ends up in the food supply, ends up in the water supply, and then people drink it and then introduce it into their own gut. So, Ben.
All right. So I'm going to breeze through the first part of this. The time when people really came to grips with cholera was 1850 in the Broad Street cholera outbreak. I'm going to recommend that you all check out an amazing book called The Ghost Map, which talks about how mapping helped solve this problem. But in short, one Dr. John Snow was convinced of this crazy idea called germ theory. He used a map to plot the location of cholera cases against the position of this pump right here, and was able to successfully make the argument that they should take the handle off the pump and see what that did to the rate of cholera happening in this area, and it pretty much stopped immediately. And then later they put it back on and it started back up again, and so then they destroyed the pump forever. This galvanized cities across the Western world to begin dealing with sanitation, even in situations where people didn't think it, where it wasn't obvious that there was pollution, because people thought this pump was great. People would come from the surrounding area to use this pump because they thought the water tasted better. This brings us over to Chicago. Very quickly, Chicago developed very strongly between 1840 and 1860, and part of the problem with that is that people were dumping sewage directly into the Chicago River, which was the main water source. So they decided to solve this by building these water intakes for a new water system several miles offshore, and you can see the distance in this map. And this was a really great big project that they were undertaking to make themselves a nice modern city. Unfortunately, in 1865, on August 2nd, there was a really huge flash flooding event from a storm that flushed through the Chicago River, which you can see over here, and flushed out a huge plume of sewage that people had just been dumping in the Chicago River. It flushed it out into Lake Michigan, and it actually did get around the new intake system that they'd built. There was a huge media outcry about this. That's been preserved in public consciousness as a memory of a cholera outbreak, but there actually wasn't a cholera outbreak at that point. However, that said, Chicago had repeated repeated cholera outbreaks, so it wasn't like that kind of thing couldn't happen. So they proposed a fancy solution. They would reverse the river. They built a dam, they built some locks, and they deepened the ship canal over here. And now the water, the horribly, horribly polluted water from Chicago, rather than gently flowing out to Lake Michigan, would be flushed through down into the Mississippi River system. That was the theory. In fact, what they did is that they just continued to push this water into a closed area, and they didn't deal with any of the causes of pollution at all. So the impact on cholera was probably minimal at best. It did keep this stuff away from the water intakes, which is something. But that said, Lake Michigan remains extraordinarily polluted today. This is after several decades of the Clean Air and Clean Water Act. Before the Clean Air and Clean Water Act, it was terrifyingly polluted. So one of the places in Chicago that was affected by this is the Bubbly Creek. It's the south arm of the Chicago River, and this whole area around it was slaughterhouses, and they were just dumping animal parts out into the river. And so you can see that this guy right here, he is standing on an island of congealed fat. All that stuff then sank down into the bottom of the river, where it continues to decompose and bubble out to this day. Although apparently they've gotten rid of all the slaughterhouses, and so it's actually picturesque, if bubbly.
I used to live in that neighborhood. It's quite nice.
In the wider world, redirecting these rivers flooded farmland in nearby areas and sent tons of raw sewage down to St. Louis, down in the Mississippi River, to the point that St. Louis sued Chicago, although they were dismissed out of hand by the Supreme Court. And to this day, this is an issue because now this water system creates the possibility that invasive species that have taken over the Mississippi are going to get out into the Great Lakes and cause ecological devastation. And so the city and the state and the government spend $2 billion annually on defenses to keep the invasive fish out, including an electrified fish fence. Chicago is still, even decades after the Clean Air and Clean Water Act, working to clean their waterways by eliminating combined sewage overflows and getting people to stop dumping waste in their waterways. So in general, this reversal of the Chicago River wasn't a huge success from an urban planning standpoint, but of course the civil engineers think it was great.
Okay.
And we are very low on time, so just
Okay, so we'll breeze through the mosquito part, which is my favorite.
Yeah, sorry.
That's fine. So I'm just going to talk about malaria and yellow fever. So both of these pathogens were actually brought over during the European trade in enslaved people over from Africa. Malaria is a parasite, and yellow fever is a virus that is related to dengue and Zika. So malaria is a parasitic infection of the blood. So basically what ends up happening is any part of your body that's actively filtering blood, so your spleen or your liver or your kidneys, all end up being damaged by the parasite. So this X-ray image is of someone's spleen. You can see it's larger than their liver. It should be about the size of a fist. And that can actually result in the rupture of the organs and death that way. Malaria also causes something called cerebral malaria. On the right is a child with a normal brain, and on the left is a child with cerebral malaria. You can see all of the normal brain wavy parts are completely swollen, and that causes pressure on the brain and eventually death. From the yellow fever standpoint, it's called yellow fever because it causes jaundice, and it's a hemorrhagic virus. So oftentimes the way that people die from it is from the hemorrhaging of small blood vessels. So they end up bleeding from the eyes, nose, ears, and it's a very similar way of means of killing people as Ebola, actually. So next slide. So the mosquito life cycle is really important when we're talking about controlling mosquito-borne diseases. So adult female mosquitoes are the blood feeders. They get blood to create their eggs. They need the protein and fats. So they lay the eggs on the water. Their larvae live in the water. They're aquatic insects, and then eventually emerge as adults. So controlling water supplies is incredibly important when controlling mosquitoes. These two particular mosquitoes, on the left is the mosquito that transmits malaria here in the United States. And on the right is the invasive species that transmits yellow fever, dengue, Zika. So both of these mosquitoes love urban environments. They can breed in very small bodies of water, and they prefer primates like people. Slide.
All right. So very quickly, so after all this was discovered, it happened to be, it was discovered largely because of the U.S. adventures in Cuba and Panama. And once this scientific link was proved, they began experimenting because they had the sandbox where people didn't necessarily have rights to stop them, but they landed on a bunch of really good interventions that would break that mosquito life cycle. Chemically, they would do things like oil the water bodies. This picture on the top right, for some species of mosquitoes, they live by having their butts hooked to the surface of the water, and they breathe that way. So if you dump an oil slick on top of the water, then they can't breathe. Then there's, of course, DDT, which is a fantastically effective insecticide and also highly toxic. And you can see a truck fogging out DDT back in the 50s. Other things that you could do, raising living standards is very important. A lot of these mosquitoes can't survive under any kind of predatory pressure, so any kind of fish. So they live in tiny, tiny little puddles of water that tend to collect on trash, or things like open cisterns often are good places to breed them. So as the United States went through and improved trash collection and rubbish disposal, hooked people up to city water, or encouraged people to use closed cisterns, that reduced the mosquito population. And of course, eventually they did discover a yellow fever vaccine, which is very effective. But the thing that is most interesting to us today is the mosquito ditches. These are shallow ditches in marshy areas that, instead of the water all collecting on top of the surface of the ground, now it'll drain down into this ditch. And what that does is it eliminates these shallow stagnant pools that don't have any fish in them. Once you've dug your ditch, you can actually buy mail mosquito fish, is what they're called, and there's one there. And you just shove them into your mosquito ditches, and they will wipe out the mosquitoes in your area. There was a widespread project by the Civilian Conservation Corps in the 30s to build these things around East Coast cities. Now, some people argue this was more of a make-work project than something that was effective, but mosquito ditches in general were very effective. And we know that because they were utilized in the mosquito eradication campaign conducted by the CDC. In fact, this campaign is, to a large extent, why the CDC exists. Originally, the CDC was there to knock down mosquito populations around U.S. Army bases in World War II, and particularly in the South, where it was an issue. After the war, they transitioned to becoming a civilian agency, but they remained with their headquarters in Georgia, which is why they're in Atlanta to this day. They went around spraying DDT in over 4 million homes. They constructed drainage ditches. They had planes flying, spraying DDT. They had trucks fogging DDT. And as a result, the U.S. was malaria-free by 1949, and yellow fever in a similar time period. And at which point they moved. The CDC at this point is sort of in a monitor maintenance phase with malaria and yellow fever. There's much more we could say about the international situation, but to this day, there are mosquito control boards in pretty much every state in the country that's even vaguely threatened by this, which is most of them. And they coordinate those activities, and the CDC helps coordinate the mosquito control boards as well. As far as the impact on modern cities, to a certain extent, they exist in the South. The pressure from malaria and yellow fever was really catastrophic at certain periods in U.S. history. And there are things like there was a yellow fever outbreak in Philadelphia, which was the capital at the time, which caused it to need to be evacuated, which shut down the U.S. government. So these eradication campaigns were very important in the economic development of the modern United States. The other thing to say, though, is that, so if you look at this aerial shot from the top, you go, oh, that's some nice farmland. There's some nice residential development over here, whatever. If you look at it down here with the aerial photographs turned off, you can see that there's just ditches everywhere, all through here, which means that before these ditches were dug, this area would have been basically uninhabitable. And now it's developed farmland and developed urban area. Whether you think that's a good thing or a bad thing can be a point of view thing, but it certainly opened up a lot of area for development. Now, this will sort of take us into challenges ahead, and the whole issue is that now we need to talk about balance. Because one of the things that we learned from dealing with mosquitoes and everything is that DDT is like horrible for the environment and humans and in general. These are the so-called DDT eggs, where the shells got so brittle from the DDT poisoning that they couldn't survive. Tons of predatory bird species were almost wiped out. Then there's social issues. A lot of the work that was done on tuberculosis happened because of these quarantines, and there was a huge social stigma attached to that. These people are so-called lungers, who were sort of banished from towns into these communities of people who were under quarantine. So just as we go forward, we're looking at more ecosystems approaches and integrated pest management. And there's also the challenge of battling chronic health issues, and park space is actually going to be very important in that, but we just need to be careful to do it in a way that doesn't introduce pests like hipsters and ticks. So that's our presentation. We're 10 minutes, or we're 6 minutes over time, so let's go straight to questions. And actually I have a question from someone who wasn't able to attend, so we'll start with that very quickly. Until modern public health systems were developed in the 19th century, cities were population sinks requiring in-migration from the countryside to maintain population stability. Cities were known to be hotbeds of disease, and people regularly fled to the countryside to escape epidemics, which occurred every couple of years. If this is the case, why did they exert such a draw on the surrounding populations that kept people coming, in spite of the known dangers? What do we know about the decision process of migrants who did choose to go into the city? We don't have anywhere near enough time to address the full breadth of this question, I'm afraid, but very, very quickly, the economics of the thing were just insane. And it should be said that it's not like everyone woke up in the morning and said, I'm going to go to the city even though there's a 30% chance I'll die within a couple of years. Like, that kind of statistic wasn't commonly available. What they did know is that if I stay here on the family farm, there's not enough food to feed me, there's not enough money to pay the mortgage, but if I go to the factory, I might be able to earn some money for my family and keep the farm going, or keep myself fed, or have a better outcome for myself. So that's basically the short answer to that question. Alex Lawson asked, do you foresee a transition away from city living as a result of COVID-19? If so, what might that look like?
So I can say, so I just, due to a family emergency, I had to move from Chicago to Spokane, a much smaller city. And I can tell you, I felt much safer in Chicago, where they had a lot of well-established hospitals. They were like doing things like converting convention centers into COVID-19 response centers. So I don't really, it's you're so much better off in a city where you're close to medical resources. Of course, I'm speaking from a place of privilege where I can just go into a hospital. But in rural areas, they're pretty well known for having difficulties keeping doctors in place. So especially well-trained doctors, and in rural areas, you're a lot less likely to have people who are like specialists, like a pulmonologist. So I don't really foresee people moving away from cities, but certainly we can see an impact on our lifestyles.
I'll follow up on that. I had a friend who moved to Louisiana for a few years, and she got pregnant, and she was very happy at one point was telling us that she got in with the OB that she really wanted to get in with. She wanted to get with that OB because it was the close one. It was only a 2-hour drive. So, you know, when you talk about with emergency medicine, you talk about things like the golden hour and like things that timing can be so important in saving a life. You know, from a health standpoint, cities are going to remain much more healthy to be in so long as our sort of the economic underpinnings that make all this stuff work continue to persist. I do think that there's going to be more telecommuting and stuff, but that I think that there was an underrepresentation, let's say, of telecommuting within the American workforce, and I think this is just going to be a corrective. Unfortunately, we are out of time. I'm sorry we went so late and we didn't get to as many questions as we would have liked to. If you guys have questions, you know, maybe email them to us, and we can try. Maybe we'll do a crossover thing on our shows or something like that if there's enough questions to justify, you know, 10 minutes of chat. So, thanks everybody, and I need to go to the next session. You can find my email from my show. Unfortunately, I really have to go. So sorry, everybody. Bye-bye. And thanks, Raven, for doing this. And thanks, everybody, for coming.
Yep. Bye. Thanks, everyone.